All right, let's take a look at question 18.23 from Klein, where we're starting with ethylbenzene. So we start with ethylbenzene, which has 1, 2 carbons off of the benzene ring, and we generate this compound that has a secondary alcohol, and we have 1, 2, 3, 4 carbons off the ring. So that means we're going to need to add carbons at some point. So we're going to need to add carbons. So let's see how we might do this. So if we took this molecule and with just an alkyl group, we don't have a lot of functionality out here, but if we treated that, what if we treated that with NBS, so N-bromosuccinimide, and we heated this? Well, we know that we have 2 benzylic protons here, so I'll just draw on one of them. And we know that if we treat that with NBS and heat, we can replace one of those protons with a bromine. So what would that look like? Let's draw this. We still have our ethyl group, but now we've replaced one of those protons with a bromine atom. And hopefully you can see right away that now that we have this system here with a bromine, if we were to remove one of the protons from our methyl group here, if we were to remove one of these, we could generate a double bond. And then when we have an alkene, which would be conjugated to our benzene ring, we'd have a highly stable system, and we'd have an alkene, so we would be able to do some interesting chemistry with that. And the way that you do this is by an E2 mechanism, and the reagent you would want to use to do that would be sodium ethoxide. So I'll write here sodium ethoxide, and that would give you this compound. And this is a compound that we talked about at the very beginning of chapter 18. It has a common name, and the name of this compound is styrene. So you've gone from ethylbenzene, and just by brominating it and then doing an E2 reaction, so I'll put this in brackets here, this is an E2 reaction, you produced styrene. So we still have 1, 2 carbons, and we need to have more carbons, so we need to find a way to add carbons to this. And the way I think about this is, if we were to have a ketone, if you look at this molecule here, if we had a ketone here, if you forget about this hydrogen here, if we had a ketone, then we could do some kind of nucleophilic attack with a Grignard reagent, and then we could think of an easy way to make this molecule. So I'll just erase that here so we don't get confused with this double bond here. So how would we convert styrene into a ketone or an aldehyde? And there's only one way that we've learned to do this very quickly, and this is a reaction that you would have covered in first semester, and that's to treat that with ozone and then do a workup with dimethyl sulfide. And what you will get in this case is what you're going to do is you're actually going to cut this bond in half, and you're going to end up losing the CH2 that's on the end, and you will end up with an aldehyde in this case. So end up with an aldehyde, and hopefully you see that through this key reaction, so this is one you'll have to remember, ozone and dimethyl sulfide, to cleave this alkene and generate this cleave the alkene and generate this aldehyde. That's a reaction you're going to have to dig up, and you're going to have to know this reaction. So you can see now it's getting more obvious as to how we would go from benzaldehyde all the way to our product. So this compound here is benzaldehyde. This is another commonly named compound, benzaldehyde. So hopefully you can see that here we have only 1 carbon, and we need to have 4 carbons. So what if we treated this first with propyl magnesium chloride as a Grignard reagent, and then 2, we'd have to treat that with water to protonate it. Hopefully you can see then that when we have our Grignard reagent, I'll just write it like this. We have our propyl, and then we have our magnesium chloride over here. You can see that this is going to be a strong nucleophile, and since aldehydes are very polarized, this carbon that is labeled 1 is going to be very electrophilic. So our propyl group is going to attack here, and we're going to get the desired product after we protonate it with water. So hopefully this helps you solve this kind of problem very quickly.